Everybody,
Sir, at least I am not sleeping, so I don't know what others are doing.
okay, okay. So, do you have any question regarding data structure, linked list? Neeraj, Suhan,
नो सर.
ओके, समझ में आ रहा है?
हाँ सर.
किस किस को समझ में नहीं आ रहा है? Anyone? You can speak frankly because this subject is very, very important. Okay, because I saw that in the last class only 57 or 58 student was present. Why? It's for all the subjects same type of attendance or only for my subject? So is my screen visible?
Yes, sir.
यस
Okay.
सर.
Okay. So in the last class, we have discussed about linked list. Okay. So when we're talking about linked list, we're talking about node. Okay. Every node, there are two parts. What are those two parts? Each node contains two parts. What are those two parts?
डेटा एंड लिंक.
Data and link part. So every node we can represent using two part. One is data part and another one is link part. Okay. So suppose we have one. So there are three different type of linked list we have discussed in this course. First one is single linked list. Okay. The second one is circular linked list, and third one is double linked list. Okay, so what is a linked list? So linked list is a linear collection of data elements called node. Linear collection of data elements called node, where the linear order is maintained by the pointer. Where linear order is maintained by the pointer. Suppose so linear, it is a collection of node. This is one node. This is another node. This is another node. And this one is another node. Okay. Suppose this node value is suppose 10. Here data part of each node contain 20. Data part this node contain 30. Data part this node contain 40. So when we create this node using a malloc or galloc function, each node has some address. Suppose address of this node is suppose 100, address of this node suppose 200, address of this node suppose 300, address of this node suppose 400. Okay, so we have 4 different node, each node data. So suppose this is a node and this node name is suppose P. So this part, which we can say data of P. Okay, within an algorithm we can write in this way, data of P. So here we insert the data, and this one is link of P. Okay, data of P and link of P. Data part contain the data, any type of data, and link part contain the address of the next node. So this we have 4 node, but this is not a linked list. Okay, now in a linked list, it's a collection of node where node stored the information and linear order. Okay, linear order is maintained, linear order is maintained by the pointer. Okay, by the link part. So this node link part contain, okay, this node link part contain the address of the next node. Each node link part contain the address of the next node. Okay, so what is the value here?
200.
200. Okay, what is the value here?
300.
Yeah.
300. What is the value here?
400.
400. So that means we established a link between this node and this node. When you insert the value, the next node address here in this link part, and last node link part value is null. Last node link part contain the value null. So this is a single linked list. Why it is called single linked list? Okay, single linked list. Why it is called single linked list? Because only a single link is there between these two nodes. Okay, that's why it is a single linked list. Okay, that's why it is a single linked. Yes.
Sir, can we also say that since it is in linear order, so we can call it single linked list?
Yeah, linear order already also maintained for circular linked list and double linked list.
Oh, okay.
Okay, so this is the linked list properties is linked list is a linear collection of data elements, collection of data elements which we called node, where the linear order is maintained by the pointer. Okay, linear order is maintained by the pointer. So this is a single linked list. Okay, because here only one link. Okay, so single linked list, in this list each node has only one address field. Okay, single linked list, in each node has, each node has only one address field. Each node has only one address field to contain the address of the next node. Okay, to contain the address to contain the address of the next node in the list. Okay, in the list. So in single linked list, each node has only one address field. So this is only one address field. Okay, and this it contain the address of the next node. Okay, in the list. This is called single linked list. Okay. Any question? Any doubt?
No, sir.
Okay. So when we are talking about linked list, okay, here we can perform some different operations. Okay, we can perform some different operations. What are the operations? Okay, we can perform in a linked list, any type of linked list, maybe single, double, circular, any type of linked list. What are the operation we can perform? First operation is called traversing. Okay, what is traversing? Anyone?
Sir, visit all the elements and to travel each and every location. And
Yes, these are the elements. It is called traversing. Okay. So suppose we have one linked list like this. The value is suppose 1, 3, 9, 4. Okay. We need to traverse from this node, first node to the last node. This is called traversing. Visit each node, and after visiting we can perform any type of operation, like we can print the value. Okay, we can print the address, whatever we can print. So visit each node is called traversing from beginning to end. From beginning to end, visit each node is called traversing. In any linked list, okay, in any linked list, maybe single, circular, double, first node is called header. Okay, in any linked list, first node is called header. Header is nothing but represent the address of the first node. Okay, header nothing but represent, what is header? Header is nothing but the address of the first node. Address of the first node. So according to this diagram, what is the header value?
10.
इसके बाद भी 10.
Oh, sorry, 200.
200.
Not store. Sir, उसका address 100.
What is header? Header is represent
Address.
of the first node. What is the address of the first node?
so 100.
100. So header value is 100. Okay. So header is a variable which represent the address of the first node. So in this linked list, what is header value? Header value is 100. Is it clear to you? So header value is 100. When we are talking about linked list, okay, please pay attention here. When we talking about linked list, each node represent by its address. Each node represent by its address. So what is the first node? 100 address wala node. What is the second node? 200 address. What is the third node? 300 address. What is the last node? 400 address. So when we are talking about linked list, each node represent by its address. So what is header? Header is nothing but the address of the first node. Okay, header is nothing but the address of the first node. So first one is traversing. Now suppose we have one node. Okay. Suppose this node name is P. Here the value suppose 10, and it. So this is no address 100. This node address 200. This node address suppose 300. This node address suppose 400, and this node address suppose 500. So one linked list already there, and we have one new node. What is the second operation we can perform? Insertion of a new node. Okay. Insertion of a new node in the linked list. Okay. Insertion of a new node in the linked list. Now, where we can insert this node? We can insert this node at the beginning, before the header. Okay. So this is my header. Header represent the address of the first node. So we can insert a node before the header. We can insert a node at the end, means after the last node. Okay. So we can perform insertion at beginning. Okay. We can perform insertion at beginning. We can insert this node at the before the header. Okay. So insert at beginning. We can insert a node at end, means after the last node. We can insert this node after this node. We can insert this node. Okay. Third one, we can insert a node at specific location. Okay. At specific location. Okay. Suppose insert a node at second position, means here. This is the first node, second node. So insert this node at this position, or insert this node at third position. So first node, second node, third node. Insert this node at the third position. So insert a node at specific location. Insert a node after a given node. Insert a node after a given node. Okay. So suppose insert this node 10 after a node whose data value is 9. So we need to insert this node. Insert this node 10, okay, after whose data value 3. So after this node we can insert this node. Okay. So these insertion operation we can perform: insert at beginning, insert at end, insert at specific location, or insert after a given node. Okay. Similarly, same operation we can perform for deletion. Okay. We can delete the first node, we can delete the last node, we can delete any node between the first node or last node, maybe any specific location. Suppose want to delete at third position node. So this is first position, second position, third position. So we need to delete the third node. Okay. Delete a node whose data value after the node whose data value is 3. So this data value is 3. We can delete that node after means this node. Okay. So deletion operation also can perform similarly, like delete the first node, delete the last node, delete the node at a specific location, delete a node after a given node. So traversing, insertion, deletion operations we can perform. Okay. We can perform also another operation which is called counting. Okay. Counting means count the number of node of a given linked list. Suppose in this linked list total number of node is 4. Am I audible to you?
Yes, sir.
Okay. So in this node, total number of node is 4. So counting is also one of the operation. Fifth is called merging. Merging means merge two different linked lists. Suppose this linked list, we have another linked list. Okay, suppose the value is 5, 6, 7. So this is one linked list, this is another linked list, we want to merge. Okay, we suppose after this linked list we want to merge this one. So merging is one of the operation of a linked list. So after merge, two linked lists join together and make it as a one linked list. Okay, so there is two linked list. After merging, it should be one linked list. So merging is also one of the operation. Next one is searching. Okay, 7 one is display. Searching means, suppose if you want to search a node whose data value is 9. So is there any node whose data value is 9? This node data value is 1, this node data part is 3, this node data part is 9. Yes. Suppose you want to know search a node whose data value is suppose 20. Is this data value 20? No. This node data value 20? No. This node data value 20? No. This node data value 20? No. So then we can say that that node is not present whose data value is 20. So this is called searching. Display, we can visit each node and display the element. So for display, which other operation also required for display?
Traversing.
Traversing. We can traverse each and every node and display the data. Whatever we want to display, maybe that node address we can display, that node link part address also we can display, or that node data part we can display. Anything we can display. Okay. Next one is called sorting and reversing. So these are the operations we can perform. Sorting means we can sort the element. So first 1, then 3, then 4, then 9. Okay. So we can sort the element of any node. Accordingly we can. And another one is reversing. Maybe this one was the first node, then this one is the second node,
Sir.
this one is the third node, this one is the fourth node. So we can reverse any linked list. Yes.
Sir, sorting means searching.
Not sorting means searching. Searching means to find any node. Suppose if we want to search to check any node is present in this linked list whose data value is 20 or not. So is the data value is 20? No. This node data value is 20? No. This node data value is 20? No. This node data value is 20? No. So 20 वाला node नहीं है जिसका data value 20. Suppose we want to search a node whose data value is 4. Is there in this node data value is 4? No. This node data value 4? No. This node data value 4? No. This node data value 4? Yes. So this one node is present in this linked list whose data part is 4. This is called searching, to search. And sorting means sort the element. Okay. Sorting means sort the element. Suppose we have one linked list like this. Suppose 6, 3, 2, 9. So we have one linked list. Now we need to sort. So after sorting in ascending order, So this is 2, 3, 6, 9. So this is called sorting. We sort this linked list in ascending order, or we can sort in descending order. Okay, this is called sorting. And reversing, we need to reverse. Suppose we want to reverse this linked list. So after reversing, so this is called reverse. Okay, sorting means sort the element, sort the data value of each node and make it a linked list. And reversing, reverse the linked list. You can see 6, 3, 2, 9. After reversing, 9, 2, 3, 6. Up to this clear?
Yes,
Yes.
sir.
Okay. Now, please pay some attention. Now I am going to write how to write an algorithm of traversing. Okay. Traversing a single linked list. Okay, we want to traverse each node and want to print the value. Suppose so we have one linked list. The address of this linked list is, suppose this node is 100, 200, 300, 400 and 500. What is the value? Suppose 6, 19, 8, 7, 20. Okay. Now, okay. So now we have to traverse from this node. So this is the first node. First node is called header. We need to traverse from first node to the last node and print the element, print the data of each node. Okay, print the data of each node. So we need to write an algorithm of traversing, okay, of a single linked list. Okay, this is the name of the algorithm. Now bracket start. What we know, we have one linked list. We know the header. What we know only the header. What is header? Header is nothing but the address of the first node. Okay, so one linked list we know the header. What is header? Header is nothing but the address of the first node. So what is the header value? Anyone please tell me, what is the header?
100.
100.
100. So this node contain the address of the next node. This part contain address of the next node. This part contain address of the next node. This part contain address of the next node. Okay. Now we declare one variable y, and because we need to traverse from this node to this node, then this node, then this node, each node we need to traverse and print the data. So we need to declare one variable y. So y equals to header. Header, which type of variable? Header and y both are pointer
Address.
type,
Point.
right? It stored the address, that means pointer type variable. So we declare a variable y and y equals to header. So here we declare y equals to header. Okay. Now we print data of y. Okay. Print data of y. What is data of y? Means y in this node y, what is the data? Data of y. So what is the y value now?
6.
6.
Y value
100.
100. What is data of y?
6.
6.
6. It will print 6. Data of y. Data of y. Y represent the address. So y is the address of the first node 100. So what is the data of 100? 100 node का data क्या है? 6. So it will print 6. Now we need to move to the next node. So any node we know this is the data part, this is the link part. If we write link of y, what is link of y? This is y. What is the link part of
200.
y? 200. So this 200 is we need to traverse from this node to this node. So if we write y equals to link of y, so now previously it is y. What is link of y? 200. So 200 is my new y. So previously we assigned y value equals to 100. Okay. Now print data of y. So data at 100, which is 6, we print 6. Now link of y. What is the y value? 100. Link of 100. So link of y is 200. Since 200 is my new y. So now y value is not 100. Y value is now 200. So now y represent this node. Y variable represent this node. So in this way we can move from one node to another node. Is this part clear to you?
Yes, sir. Clear.
Yes, sir.
Totally clear. कोई भी problem है तो बोलो. It is very important. Otherwise you will not able to write a single algorithm about any linked list.
Hello, sir.
Yes.
Sir. सर एक बार फिर से बता दीजिए.
Yes. Hello. Yes. Sorry.
सर y इक्वल टू लिंक बता दीजिए एक बार फिर से.
Okay. Yes. Okay. Suppose previously, what is the y value initially? Okay.
100.
Okay. What is the y value? Y represent the header. Each node represent by its address. तो हर नोड को मैं एड्रेस से रिप्रेजेंट करूंगा. Each node represent by address. Okay. Now y header, what is header? Header is nothing but the address of the first node. What is the address of the first node? 100. So header equals to 100. We know only one linked list. We have one linked list and we know the address of the first node, which is 100. Okay. Suppose you have one hostel. In your hostel, you know only the starting room number. Starting room number is 100. So if you know the starting room number, then you can traverse from 100 to 101, 102 and 103 like this, from next room, then next room. Similarly, we know we have one linked list, and we know the address of the first node, which is called header equals to 100. Now we need to traverse. Traverse means visit from one node to another node, from first node to the second node to the third node, from first node to the second to third, and so on up to the last node. Okay, so we declare y equals to header. So we declare a variable y and initialize this variable y by header. So what is the y value initially? 100. Because header value is 100, y value also 100. So header y, these are nothing but the pointer. These are nothing but pointer because it holds the address. Okay. Now data of y. Data of y. Y represent now this node. What is the data of y? Data part में क्या है? 6. Okay. So data of y is 6. We print 6. Now comes to the next line, link of y. So this is the any node of every node. These are data part, and this is the link part. Okay. So how do we know? Because this node link part contain the address of the next node. इसके पास next node का address है. This node, each node link part contain the address of the next node. So this node link part contain the address of the next node. So what is the link of y? This is y. What is the link of y? 200. So 200 is my new y. So now y value is not 100, y value is now 200. So y now represent the next node. Okay. Now print data of y. What is data of y? Tell me.
19.
Sir,
19. Data of y is 19 because y represents this node. So data of y 19. What is link of y?
300.
300. So link of y value is now 3. Link of y. What is link of y? 300. So 300 is my new y. So y is my now this one. Now what is data of y? What is data of y? 8. Okay, y का data part में क्या है? 8. So data of y 8. Now what is link of y? Y link value is 400.
400.
So 400 is my new y. So this is my new y. Now y value is 400. Okay. Now what is data of y? What is data of y? 7.
30.
30. This is y. What is data of y?
7.
And 30 कहां से आ गया? अजब है सब. So this is y. Data of y is 7. Okay. Now what is link of y?
100.
Link of y is 500. So 500 is my new y. So this is my new y. Okay. 500 is my new y. So now data of y. What is data of y?
20.
20. Data of y is 20. What is link of y? Null. Okay. That means if link of any node. So how do we know in a linked list, single linked list, which one is the last node? How do we know?
If the link is null.
If the link part,
If any
link is
node
not
link
present.
part is null, yes, link part is null, then it is a last node. Okay. So can we write here while link of y not equals to null, okay, then we traverse. Link of y not equals to null, can we write?
Yes,
Sir,
sir.
if the first link is means if the first link is null, then
First link is null means?
means if there is a circular link list, so in that the
No, so,
last
but now forget about circular link list. Now I am talking about the single link list. Okay, suppose you have okay. Suppose you have one node and this node, suppose linked list contain only one node. So this node is null, the value is 100. So this is my header. So this is my header and this is my tail. Means this is the first node and this is the last node. Then also no problem. Y equals to header. What is y? Y equals to header 100. Now link of y not equals to null. No, link of y is null. Okay, so link of y is null. So this condition is not true. This condition is not true. Okay.
okay, sir.
Yes, later we will discuss about the circular and all. Now, please pay some attention. Here we have written here link of y not equals to null. Link of y not equals to null. Okay. What is y? Initially, y equals to header. So y value is 100.
Sir.
1 second. Y value is 100. Okay. So y value is header. Header. What is the header? Header is nothing but the represent of the first node. So first node address is 100. So y equals to 100. Now link of y equals to null, not equals to null. What is the link of y? What is link of y?
200.
200. So first 200 not equals to null. Yes or no? Because 200
sir.
is not equals to null. 200 is a value. So 200 not equals to null. Yes. Enter data of y. So what is data of y? 6.
6.
Okay. Now link of y. What is link of y? 200. So 200. So 200 is my new y. So y represent here. So this is my y value is now 200. Now again check link of y. What is link of y? What is link of y?
19.
What is link of y?
300.
300. So 300 is my link of y. So 300 not equals to null. Yes, 300 not equals to null. Now print data of y. What is data of y? 19. Okay, data of y is 19. Now link of y. What is link part of y? 300. So 300 is my new y. So now this is my new y. Because this node data value is 300. Address is 300. Now link of y. What is link of y?
400.
400. 400 not equals to null. Yes. Enter into the loop. Print data of y. What is data of y? 8.
8.
We print 8. Now link of y. What is link of y? 400. 400. Link of y is 400. So this 400 is my new y. So this 400 is my new y. Now link of y. What is link of y? 500. 500 not equals to null? Yes, 500 not equals to null. Print data of y. What is data of y? 7. We print 7. Now link of y. What is link of y?
500.
500 is my new y. So this 500 is my new y. Okay. Now link of y not equals to null. Yes or no?
False.
False. Now you can see y का link part null है. Link of y is null. So this condition is now false. So if we write this condition, it will print all the node data except the last node. Except the last node. So that means this condition is not true. Okay. If you want to print, if you want to traverse each node from first to last and print all the element. If we write this condition, we can print all the nodes data except the last node. Okay. So how do we modify this one? Instead of this, if we write okay. Instead of this, if we write y not equals to null, you can see what is the address of the next node. After this node, what is the address of the next node? Null. Yes or no? So that's why this node link path is null. So what is the address of the next node? Null. So if y not equals to null, no, y value is 500. Y value is 500. So 500 not equals to null. So insert this, enter into this loop, print data of y. What is data of y? 20. It's print 20. Now link of y. What is link of y? Null. So that which is y. So this is my y. Now check what is y value? Y value is null. So exit from the loop. Okay. If you want to print up to the last node, then you need to write y not equals to null. Any question? Please spend some time here in this slide and ask any question, because this concept is very important. Okay. So initially y equals to header, y equals to 100, y not equals to null, no, y value is 100, y not equals to null, no, 100 not equals to null, print data of y is 6. Now link of y is 200, so 200 is my new y, so y is now 200. Y not equals to null, yes, y value is 200, 200 not equals to null, print data of y is 19. What is link of y? Link of y is 300. So 300 is my new y. So this 300 is my new y. Okay. Now y value is null? No. Y not equals to null? Yes. Y value is 300. 300 not equals to null. Now print data of y. What is data of y? 8. Print 8. Now link of y. What is link of y? 400. So this 400 is my new y. So this 400 is my new y. Now again check. Y not equals to null? Yes. Y value is 400. 400 not equals to null. Now enter into the loop. Print data of y. What is data of y? 7. We will print 7. Now link of y. What is link of y? Link of y is 500. Link of y is 500. So 500 is my new y. So this 500 is my new y. Now check. Y not equals to null? Yes. Y value is 500. 500 not equals to null. enter into the loop. What is data of y? Data of y is 20. So it will print 20. Now link of y. What is link of y? Null. So null is my link of y null. Null is my new y. So this is my new y. Okay. Y not equals to null? No. Y value is null. So exit from the loop. Any question? Any doubt?
No, sir.
Okay. So any single linked list, each node represent by its address. पहला node का address 100, second node address 200, next node address 300. So header y represent the address. So y nothing but the represent the address. Y is a variable which holds the current node address. So initialize y by 100, then we move 200, then y value 300, then y value 400, then y value 500, then y value null. Okay. Data of any y or x, data of any node is nothing but the data field. Okay, data part 6, 19, 8, maybe it's a character, integer, any type of data. And link part, so this is the link part. So link part contain the address of the next node. So link of y here, if it is y, so link of y is 200. When it is y, link of y is 300. So 300 is my new y. So this is my new y. Link of y is 400. So 400 is my new y. So this is my new one. Okay. So for any node P, suppose node name is P, here the value is suppose 20 and here the value is suppose 800 and the address of this node is suppose 300. So we can write, when we write any algorithm, data of P equals to 20 and what is link of P? Link part of P equals to 800. Okay. So link part means which this is the link part of this node and this is the data part of this node P. So data of P is 20 and link of P is 800. Okay. Any doubt, any question? Because this is very, very important, this part.
So,
Yes.
so the condition that we have written earlier in the while loop.
Link of y not equals to null.
Yes, sir. The condition earlier that you have written, sir. This we have
Yes, link
modified.
of y not equals to null.
Sir. So in that case, can we use do while for that, sir?
No. If do while loop also you can use.
And no, sir. Do while and the null part means the first link is the null, and then we use the other link.
First
as
link
to-
is the null.
Yes, sir. First link is the null. Then
First link means here
sir,
we put null.
yes, sir. And then
No,
so
this is not the single linked list. I have never seen this type of linked list. The single linked list like this, the first node, second node, third node, and so on. First node holds the address of the next node, and the last node link part is null. This is the common definition of the single linked list. If you want
sir,
to put here null, how can we connect with the second one? You are saying that here we need to put null. If we put null, any node link part contain the address of the next node. If we put here null, how to connect with the second node? Tell me.
no, sir. That I was not knowing, no, sir.
Yes?
Yes, sir. Got it, sir. That I was not knowing that the first link should not be null. Sir.
Yes, yes, yes.
Okay, sir. But sir, can we do if it is circular, then can we do no? Do I?
Yes, yes.
Okay, sir.
We'll discuss. Have you read linked list in before in school level?
No, sir.
Okay.
Yes, sir.
Okay. 101,
Present, sir.
119,
Present, sir.
148, Sanjeev Chaube, 148, 165,
Present, sir.
168, Tushar Sahu, 205, Kumar Hars, 207, 213,
Present, sir.
227, Rohan Narayan, 229,
Present, sir.
294,
Present, sir.
318,
Present, sir.
320,
Present, sir.
353,
Present, sir.
3479,
Present, sir.
Present, sir.
491,
Present, sir.
567,
Ye-
Rishabh Pathak,
Yes, sir.
575,
Yes, sir.
651,
Present, sir.